VHDL language, what are the features of VHDL language, and what is the purpose of the VHDL language. Basically, VHDL is a very high description language. It is mainly made for the hardware description. Whatever the digital circuits are available, we have to check the performance of these digital circuits with the help of this language. So what are the components of this VHDL language, that we will see first. So there are basic 5 components of VHDL language. One component is your library. This is the basic requirement of any language. And second one is your entity. And third one is your architecture. And fourth one is your configuration. And fifth one is a package. These are the 5 components of this VHDL language. Now here we'll see the program format of VHDL language. Basically this language is a case insensitive. Case insensitive means what? You can write the statement in uppercase as well as a lowercase. Doesn't matter, and every statement is ended by a semicolon. We know that in C language, each statement is ended by a full stop. But here the statement is ended by a semicolon, and it is a IEEE standard language. IEEE community is forming some rules, and these rules are followed by this VHDL language. So these are the important features of the VHDL language, and these are the 5 building blocks of this VHDL language. So library, you know the library means what? It is a collection of the pieces of codes. These are going to be used for any language. So here there are many types of library. So we will discuss this library later on. First we will discuss what are the components are very essential for writing a code in VHDL language. So these are the 3 components are very important to write a code in VHDL language. So let us will discuss about the library format and the entity, what in by entity and what in by architecture. So we will discuss this syntax of library, entity and architecture one by one. Just pause. So library is one of the important component of VHDL language. So let us see the syntax of the library. So library is a collection of pieces of code, and that can be used by any program. Okay, it can be reused by any program. So to declare a library in the program, so we need two lines there. So we need 2 things there. So which library we are using and how we are going to use that library. So that's why name of library is essential to declare a library in the code, as well as what kind of packages you are going to use. For that purpose, use clause is used. That's why first line of any declaration of library is a library and library name. What is the name of the library you are going to use in your program? And second is the how you can going to use that library, means what kind of packages you are going to use, means what kind of data types you are going to use, what kind of data objects you are going to use. Every information is available in the package. That's why use a clause is used. That's why how to write a use clause. For that purpose here, library underscore name underscore package name dot package parts. So here in the VHDL language there are 3 libraries. One library is your IEEE library. First is your IEEE library. Second one is your standard library. And third one is your work library. These are the 3 library. So in our code we are going to use the IEEE standard library. We are using the IEEE library. So let us, I am going to show the how we are to write the library name and use clause for our program. So here I am going to show the 3 libraries. So first library is your IEEE library, second library is standard library, and third library is your work library. So these are the 2 important lines to declare a library in the VHDL code. So library, what type of library you are using, so what is the name of that library. Here we are using IEEE library. And then next is the use. What is the use of that library, means what packages you are going to use, what type of data types you are going to use, that is to be mentioned under this package. So that's why IEEE dot stlogic underscore 1164 dot all. The meaning of this stlogic 1164, this package means what? Here this specifies the 8 level and 9 level logic system. 8 level and 9 level logic system. And next one is your library, so standard library. So your library, name of library is standard and use std.standard.all. This is the package. Which package you are using means what type of data types are used under this library. That's why a use clause is mentioned. Similar for the library, work is the name of the library and its use is mentioned here work.all means whatever the data types related to that work is mentioned under that. One more is there regarding this point. Use IEEE underscore std logic dot arith dot all. The meaning of this sentence is what? std logic arithmetic. Arithmetic means what? Here you are using the arithmetic functions. Suppose you want to do the addition of any two numbers, any logical functions and ending operation, ORing operations or any operations. In that case you need this arithmetic package. Arithmetic package means what? It includes the signed and unsigned data. This is the meaning of this std logic arithmetic dot all. Okay. Library. Now we see the second component of the VHDL language is the entity declaration. So entity declaration, entity means what? It gives the list of input and output port of the system. What are the input pins and output pins of the system? Just we take a very simple example for any system. For example, for your washing machine. So what are the inputs are there, what are the outputs are there? You can take any example of the lift. You take the example of the elevator, lift controller. So we know that for lift, what are the inputs and what are the outputs. So that we are going to have to mention with the help of entity. Just take the example of half adder. We know the half adder, two inputs and two output. Means A and B are your input and sum and carry are the output. So that we are going to mention under this entity. Entity, it gives the list of input and output port of the system, and how we are going to mention this input and output port of the system with the help of this entity syntax. So means input, what data you are going to send, whether your data is an integer, real or float, and what kind of output you are getting from the system. So just you should know the type of the data coming from the output. That's why here in the port. So here in the entity, this is syntax. Entity name. You can give the any name for your entity. You can give any name for your entity. Then is. So here I mentioned the entity name is. Then port. Port means here this very important word here, that is port. So under this port you have to mention what are the input port and output port. That's why here port name. Then colon, then signal mode. What is the mode of that port, whether it is the input mode or output mode? Basically there are four modes. One is your what? In, out, and buffer. These are the four modes. Okay. And now what is the type of data coming through that signal? So here we have to mention the data type of that signal coming from that port. So here we see here very simple point here. So again you can show how many ports are there. You have to mention here, that is I am going to write signal, mode and signal type. Give the semicolon for after the each port name, and like this way last port name, give the semicolon outside the circle. Then end your entity. So what is the name of your entity? Entity name, give the semicolon. I will take a very simple example of, I want to mention the entity for the half adder. So for the half adder, this for a half adder. So you take a this is a block. So these are your inputs A and B. This is your half adder, and sum and carry are the output. So I am going to mention the entity for half adder. Let us will take a very simple example. Let us will see the how we are going to write the entity for this half adder. So I will mention here for the half adder. Just take very simple example of half adder. This is my half adder. I will write the here entity half adder. 1 is, you can give any name, whatever you like it. Then port, in bracket, A and B are my input ports. So I will write here A, comma B, colon. I will write here data type, here is my in. This is my input port in. ST logic, data type I mentioned, give the semicolon. Then sum and carry. These are my output ports. I will write here out. I have to mention the data type ST logic. Do the semicolon after the bracket, and now here I have to end my entity half adder 1. In this way, you can specify the declare the entity here in the VHDL program. So architecture, this is the third component of our VHDL language. So architecture means what? It describes how your circuit will behave. Means here in the architecture we are writing the function of the system. We are writing the working of the system, how your system will work. So this is very important component of VHDL language. First one is what library you are using. Second one is what are the inputs and outputs for your system. And third one is how your system will work or how your system will behave. So that will be defined with the help of architecture. So architecture includes two parts. One part is a declarative part, and second part your execution means code. And this is mentioned with the help of syntax. Every component needs a syntax to specify the information. So similar way here architectures, how we write the syntax for architecture? Architecture, then write the name of architecture and write the name of architecture name, and this architecture is associated with your entity because entity contains the list of input and output. So architecture name of entity name is, and here you have to declare any things. Declaration, declarative part. Declarative part. Then begin. This begin means it is the start of your code. And here we write the code. And then add your architecture. Architecture name. It means architecture, it gives the information about your circuit functioning, how your circuit will work, and that working we are writing with the help of this architecture. This is your architecture body and this is your declarative part of your architecture. Means suppose if any signal will be constant. For example, if you want to calculate the area of the circle, we know that value of pi is constant. That you can declare here. Any declaration. And begin, here you write your logic. Code means you can use any statement. Here we write a sequential statement or concurrent statement. Here we write the statements to mention the working of your system. And then add your architecture. So we will take the same example of half adder. So write your half adder, you know AB are the inputs and sum and carry are the outputs. So I will mention here in this case, so I will write the name of architecture. I will mention name of architecture. You can use same name, half adder. 2 I will write here of entity name. Entity name, we are given the entity name for the half adder 1. So I will write here half adder 1 is, there is no declarative part, very simple circuit. We don't require. begin, then I write a logic. What is the logic of your half adder? So you know what is the equation for a sum? What is the equation for a carry? So here we write simple statements. So sum and carry. So here sum and carry, you can here very important operator is used in case of the VHDL language, that is a assign to operator. This is called as a assign to operator. Assign to operator. So here is what? A XOR B. That is XORing operation is happened on A and B signal. This is assigned to your what? It is assigned to your what? Sum. It is assigned to your sum. The XORing operation will be happen and this is assigned to S. Similar way, A and B is assigned to carry and end your statement. And here I write the name of architecture, half adder 2. Half adder 2. This way you can write the architecture of any system.